Hello everyone. In this video, we're going to discuss two topics related to the advanced use of loops. First off, we're going to talk about using the break reserved word in order to get an early exit out of a loop. We've seen break before when we were using switch statements to get an exit out of the switch structure in a case statement. We're also going to talk about nested loops. We've seen nested loops before in our last video when we were writing up code for a do-while loop in our guess my number fun code. We nested a while loop inside of that do-while loop. So let's take a look at the notes for today so we can get started working with advanced loops. We want to code up a file called advancedloopfun.cpp where we can see an example of a break statement and we can see an example of another nested loop. So let's code up an example problem here where we can apply the break statement. Let's prompt the user for words until the user enters the word stop. So that will kind of be a special sentinel value that we're looking for. We will make an infinite loop. To do this, then break out of the loop when we encounter stop. So to make an infinite loop, we can use a do while or a while loop. I'll use a while loop. So our infinite loop is while true. Our Boolean condition is just the bool value true, which means that it's infinite. It's not based on a variable's value or a flag variable, for example. It is true. So this is an infinite loop. Inside our infinite loop, we want to prompt the user to enter in words. In order to get a word from the user, we're going to need a string variable. So let's include the string library. And declare a string called word. Next, we'll want to prompt the user to enter the word, letting them know the special word stop that they'll need to specify if they want to exit our program. I want to put stop inside of double quotes, but typically a double quote is used to denote the end of a string, but this isn't denoting the end of the string. This is denoting a quote we want in the string. So we'll have to escape the standard purpose of a double quote by using a backslash in front of it. We've seen a backslash used in front of a character before to escape the normal purpose of that character. Can you think about where we've seen that before? Most commonly, we see this with the new line character, so /n. /n is an escape sequence that's used to denote a new line character. So this is the escape sequence used to denote a quote that should be used inside of a string. So now would be a good time to save, compile, and test our code. We've got an infinite word, so an infinite loop. So no matter what we enter in here, our program is just going to continue. But that's what we want so far. So Control-C to kill that infinite loop. Now we've got to test to see, did the user enter in the special word stop? If they do, we want to exit this loop. And we can do that with break. We're stuck in this infinite loop until we enter in stop to exit, and then we enter in stop and we exit out of the loop. So in summary, break can be used to get an early exit out of a loop without waiting for a Boolean condition to be false, or in this case, there is no Boolean condition that can ever be false, so the only way to get out of this loop is by breaking out of it. The next topic that I want to discuss is nested loops. So a nested loop is a loop inside of the body of another loop. We've seen this before with if statements. We can put any type of loop in the body of any other type of loop, like a for loop in a for loop, or a for loop in a while loop, or a do while loop in a while loop, etc. We just want to be conscientious of a few things. First, we want to indent the bodies of the loops so that our code is readable. For example, down here, all of the code that is part of this outer for loops body is indented at the same level. And then the code that's part of this inner for loop is indented at one level further. So it's easy for our eyes to see which code belongs to the body of which loop. We also want to make sure that all of our loops have progress towards their Boolean conditions becoming false, and that at the start of our inner loops, we are correctly initializing or reinitializing our control variables for those inner loops. We saw this as an example in a previous video when we were nesting a while loop inside the body of a do while loop. Now, I want to take this example and walk through it step by step using a table so that you can see how to debug a nested for loop and just give you a better sense of how they work anyways. So let's go ahead and copy this code and paste it in our advanced loop fun.cpp file. And I'm going to add a cout statement to the end of it, just so we can get a new line before our prompt in our terminal. So before we run this code, I want to do a hand trace of it. In fact, I've written it up here on the board so that we can make a table right here and walk through the values of I and j and see how those values affect the output from the code. We've got two loops here. The variable I is the loop control variable controlling our outer for loop. The variable j is the loop control variable controlling our inner for loop. So let's take it from the top. Initially, I is 0. We test, is I less than 5? It is. So we enter the body of our outer for loop, and we print out I and a star. So the value of I is 0. Then we come to our inner for loop, where we initialize j to 0, and then we test, is j less than I? Is 0 less than 0? It is not. So we do not enter the body of our inner for loop. We come down here to the next line of code in our outer for loop body and print out a new line character. So that's one complete iteration of our outer for loop. This is the output from that first iteration when I is 0. Now we increment I. We test, is I less than 5? It is. We enter the body of our outer for loop again. We print out the value of I and a star. We come to our inner for loop. We initialize j to 0. We test, is j less than I? Is 0 less than 1? It is. So for the first time, we enter the body of our inner for loop, and we print out the value of j and a space. So that's 0, space. Then we come up and we increment j. J is now 1. We test, is 1 less than 1? J less than I? No, it is not. We're done with our inner for loop, this iteration of our outer for loop, and we print out a new line character. And that's all of the output that we get from our second iteration of our outer for loop when I is 1. We come back up to our outer for loop. We increment I is now 2. We test, is I less than 5? It is. So we print out the value of I and a star. We come to our inner for loop. We initialize j to 0. We test, is j less than I? 0 is less than 2. We enter the body of the inner for loop, and we print out the value of j and a space. We increment we increment j. J is now 1. We test, is j less than I? It is. We enter the body of the inner for loop, and we print out the value of j and a space. We increment j. J is now 2. We test, is j less than I? 2 is not less than 2. We're done with this inner for loop, this iteration of our outer for loop, and we print out a new line character. We are now done with the third iteration of our outer for loop. We come up, we increment I is now 3. We test, is 3 less than 5? It is. Print out the value of I and a star. We're at our inner for loop. We initialize I to 0. 0 is less than 3. We enter the body and print out the value of j and a space. Increment j. 1 is less than 3. Print out 1 and a space. Increment j. J less than I, 2 less than 3, it is. Print out 2 and a space. Increment j. Is j less than I? Is 3 less than 3? It is not. We're done with the inner for loop. Print out a new line. We are now incrementing I for our next iteration. We test, is I less than 5? 4 is less than 5. We print out 4 and a star. We enter the body, we begin to execute our inner for loop by initializing j to 0. J is less than I, 0 is less than 4. We print out 0 and a space. Increment, 1 is less than 4. Print out 1 and a space. Increment, 2 is less than 4. Print out a 2 and a space. Increment, 3 is less than 4. Print out a 3 and a space. Increment, we test j less than I. 4 is not less than 4. We're done with our inner for loop. We print out a new line character, and that's our output from our fifth iteration of our outer for loop. We increment I. I is now 5. We test, is I less than 5? 5 is not less than 5. We are done with our outer for loop. We come down to our first executable line of code outside of the for loop, which is just a new line character. So this is our output of this nested for loop here. We'll head over to Advanced Loop Fun, run it, and see if our output matches. Here's our output here, which does look like it matches our output we have here. We've got 0, 1, 2, 3, 4 in the first column, stars, and then heading out blank, 1, 2, 3. Yep, looks like it matches. All right, so you can easily see with this example how crazy nesting can get with loops. Imagine if there was another for loop in here. Perhaps we had for k is 0 and k less than j. You can see how a table could really come in handy tracing through this nested for loop. My advice is always have paper and pencil nearby so that you can debug or trace by using one of these tables. It really, really helps. So this wraps up the couple topics related to advanced use of loops that I wanted to talk about. There are a few more advanced topics related to loops. For example, the notion of a continue statement. There's a reserved word in C++ called continue, and what it does is essentially continue on to the next iteration of this loop. So it's a way to kind of get an early skip of this iteration to the next one. I'm not going to cover it here in the video, but you're more than welcome to read more about continue and some of the other advanced looping constructs that are available in C++.